In May of 2015, I wrote this blog post. Do you really want bank-grade security in your SSL? And then I went through and I took a look at a bunch of large Aussie banks to see how they stacked up. How good is their SSL implementation? Now I want to show you what I found, and then we'll talk about how easily SSL can be misconfigured. So here's what I did. I took the banks that you see listed here and I assessed them against a whole range of different SSL attributes. Now just to be clear, SSL is now a bit of a colloquial term. SSL in terms of the Secure Sockets Layer protocol that came to prominence in the 90s has now been superseded by TLS, the Transport Layer Security Protocol that we saw emerge in late 1999 and we now consider to be the standard for HTTPS communications on the web. But be that as it may, one of the things that I assessed these Aussie banks on was how many of them still supported SSL, and in particular SSL3, the last version of the SSL protocol that was used. Now SSL effectively died in 2014 when the poodle bug was discovered, so it definitely should still not have been used in the following year. I also assessed them on who still had certificates that implemented the SHA-1 hash, a cryptographic implementation now considered weak. And in fact, support for SHA-1 is considered serious enough that Google Chrome presently warns against any websites that use it. I then looked at who supports TLS 1.2, so the current version of TLS, who still supports the RC4 cipher, something that we do not want to see in any SSL implementations today. Plus I looked at forward secrecy support and who still had a poodle vulnerability, whether that be due to SSL3 or due to the subsequent poodle vulnerability that was discovered in TLS. Now, as you can see here, there's a pretty broad range of results. And all of these were assessed using a tool from Qualys that I'm going to show you in a moment. And Qualys assigns a grade. And obviously A grade is good, B grade is a little bit worse, and by the time you get down to F, you are failing rather badly. Yet here we are, banks, multi-billion-dollar banks, failing terribly at their SSL implementation. Not just one or even two, three of them failed very badly. And in fact, out of this whole list, there are only 5 banks that even made an A grade, albeit 3 of them with an A-. So clearly, banks are not faring very well at their SSL implementation. Now the relevancy to this module is that misconfigured SSL can be a serious risk. And it's a perfect example of how configuration on a web server can go wrong. And this is generally something which is configured on the server itself. This is normally not something that you set up in an app, so it's very much the domain of a server administrator. Let me show you how to run one of these checks, and then we'll also talk about how to strengthen the SSL implementation. This is SSL Labs from Qualys, and what's great about this tool is it makes it very, very easy to assess the SSL implementation of any site. So we can drop in a domain name like this one, our sample vulnerable site, and then submit the form. Now Qualys goes away and simply does some external checks on the implementation. So what I mean by that is that Qualys is not running on the target server itself. It's simply looking at the way that server communicates via SSL. So let's allow this to finish and then we'll come back in a couple of minutes. Okay, here we go. Qualys has come back and given this site an A grade. Now that might seem a bit odd for a site that's deliberately designed to be vulnerable, but the reason that the Hack Yourself First site gets an A grade is that it's running on Azure websites, and in particular, their platform as a service offering. Now what that means, if you think back to the first module, where I compared infrastructure as a service and platform as a service, is that Microsoft is managing the middleware. So they're actually managing the SSL implementation for me. And clearly they've done a good job. That's why I have an A grade. Now, as I scroll down through this report, we'll see a whole raft of different areas that Qualys has tested. So for example, it's tested protocols, and it's telling us here that yes, all of the TLS protocols are supported, and no, none of the SSL ones are. Now this also goes to the point I made in the introduction of this module about what we thought to be good yesterday no longer being good today. SSL was fine if you go back far enough, before the days of TLS, but now it's so bad that we should not be using it anywhere. The times have changed, and the web server configuration must change with it. As we scroll down further, we see things like the protocol details. So is this implementation at risk to, say, the beast attack, or poodle, either in SSL v3 or in TLS? Is RC4 supported? Does the site implement forward secrecy? What about strict transport security? I talk about that one in my Introduction to Browser Security Headers course, as well as the next one down, Public Key Pinning, or HPKP. So this is a really comprehensive set of tests, and it's a great way of showing how a web server can be misconfigured, and then of course giving you information on what needs to be done to strengthen the implementation. If SSL3 is enabled, disable it. If RC4 is being used, get rid of it. If you're still using SHA-1, move forward to the newer generation of hashing algorithm. All of these things are easily discoverable in this report. And certainly one of the things that you want to do as an ethical hacker is look at this SSL implementation and point out any weaknesses, particularly the ones we just saw in that blog post about the banks. They would be very important findings in any website security test. So that's SSL. Let's move on and look at one more thing, and that's weaknesses in default configurations.